So guys, last time we started you guys remember that we had a window, like the last window, we didn't place the problem here. So let's get it done, and then we move to a different topic. I think we were almost done. Like we had the last equation, but I'm gonna do it again to refresh your memory.
I'm not going to show you my test result. 22%.
Yeah, so one last thing. Next Tuesday, I'm gonna be present in Miami. Like, I will not be in Miami. So what I'm gonna do, I'm gonna send you a recording of the lecture. You watch it, and then we are gonna continue on Thursday. That's okay. All right. So today, let's finish this problem. So our problem was on absolute motion analysis. So my absolute is a bar that is changing in length and also rotating. So it has linear movement and rotational movement. It has closed movement. So we had like a window, like something like this, like your window, and it's can open this way, circularly, like there's a glass window or something, and it can open or close. And I told you that this distance, you guys remember, was 2 meters. So you guys tell me, what is the length of this glass window? It's 2 meters because it has to close at 2 meters. So this 2 meters is here, and it's moving here. And we have like an arm, a hydraulic arm, and this hydraulic arm at the mid here and connected here. So it's something like this. And you have something like that. And this arm can be long, can be short, depends on how is the window opening you would like to have. Okay? Alright, so we agreed last time, actually they gave us this problem that says that the V of this arm, the Vs, that means how this arm is getting long or short over time, the linear velocity of this arm is 0.5 meter per second. That's like very, very slow. And it get long with constant acceleration. So the the velocity is constant. So the acceleration of this arm, as is equal to 0 because this velocity is constant, doesn't change over time, doesn't increase or decrease. Okay. So that's what given in the problem. Some geometry. So what is asking for? So let's say this is an example. It's asking for determine the angular velocity. Angular velocity means omega, and the angular acceleration means alpha at theta equal to 30 degrees. Right? You guys remember from last time what did we do? We solved a geometry problem. We need to identify what is constant and what is it changing. What is this lenses? This and this. This is 2 meter. So this wind is 2 meter, and this at the half, so this is 1 meter and 1 meter. And I know that this distance also is 2 meters. Okay? So this distance, as we agreed last time, is constant, and this is constant. What is changing is the S. Okay? So let's take the geometry problem outside. We have a window like this, and this is the opening, something like that. Circle. So it's here. You have a line. Okay? And you have an arm that is changing in the length, so it's connected to the midpoint here. So it's something like this. So I know that this is 1 meter, and this is 2 meter, and this is S. S isn't changing. What else is it changing? The angle here is changing, theta. If theta got increased, S is gonna be increased. If theta got decreased, S is gonna be decreased. Okay, so what we need to find out, we need to find S as a function of theta. We need to find these two. Because we know, if we got S as a function of theta in an equation, we can differentiate this equation to get velocity out of S, because we know if we differentiate S, we get velocity, angular velocity. If we differentiate theta, d theta dt, we get angular velocity. So if we were able to find an equation that can link S with theta, we will be able to find what we are looking for, omega and alpha. So let's see how we can do it. If you guys remember from last time, there's a rule, it's called the law of sines. We can use it. Read this like old stuff that you guys learned in math. Do you guys remember the rule of sines? Like if you have a triangle and this is angle A, B, sorry, let's make this is A, B, C, and this may be theta, P, X, E. So do you guys remember we need to link the angles with the edges of the triangle? How we can do it? How we can do it? Like A, this line over sine the angle that is opposite, sine theta, is equal to B over sine the angle that is opposite, which is C. With the second thing, C over the angle sine theta. This is the rule of sine. So there's lots of rules like this. You need to have it in your memory. I believe I put them in the equation sheet. So get back to the equation sheet. Same thing with this. If you know theta and you have theta and you have the line is opposite, the agent that is opposite, so you can say that S squared is equal to this is squared plus this is squared minus 2 this cosine this. So this is gonna be 1 squared plus 2 squared minus 2 multiplied by 1 multiplied by 2 multiplied by cosine theta. So this is the law of cosine. So this will give you that S squared is equal to 5 minus 4 cosine theta. You can do it by geometry, as I said last time. You can make a triangle here. You get this line is going to be 1 sine theta, and you make a line here. This is going to be 1 cosine theta, and this is going to be 2 minus 1 cosine theta. And then you have a triangle. You get S squared is equal to this squared plus this squared is going to give you the same thing. Right, so we have right now S as a function of theta. So I don't need S, I don't need theta, I need omega and alpha. To get omega and alpha, I need to differentiate this equation. It's not an earthquake, right? So we get d dt for this equation. So if I want to differentiate this, and I feel that you guys, every time you forget how to differentiate something, like variable S squared with respect to different variable. You guys know how to differentiate variable with respect to the same variable. But when I put this, you confuse it with that. If I differentiate variable with respect to the same variable, it's going to be 2s. That's it. But if I want to differentiate a variable too with respect to a different variable, it's going to be the same thing, 2s plus another thing, ds dt. Same thing, if you have cosine theta, okay? If you want to differentiate cosine theta with respect to the same variable theta, it's going to be negative sine theta. But if you want to differentiate cosine theta with respect to different variable dt, so this is going to be negative sine theta multiplied by d theta dt. You need to have this in your mind. If we are differentiating with respect to the same variable, it's going to be this. But if we are differentiating with respect to different variable, you will have to have ds dt at the end. Okay? Why this doesn't have something in the end? Because this is going to be ds ds. The time that the rate of the change of s with respect to x, which is going to be. Okay? So you need to have this in mind. Okay, so let's do this. I'm going to differentiate s with respect to t, so I'm going to have 2s ds dt is going to be equal to, I'm going to differentiate the whole equation. 5 is going to be 0. Negative 4 cosine theta. You guys tell me what is going to be the derivative of negative 4 cosine theta with respect to t. 4 times theta. Negative 4. And then I differentiate this. What is going to be? Negative negative sine theta, and out d theta dt. Okay? Alright, so what is ds dt? What is the time rate of change of the displacement? Velocity. So I have 2s multiplied by v equal to negative 4, negative is gonna be 4 sine theta. What is d theta dt? Omega. Alright, I got the first equation. Let's do another derivative. This is much more difficult. Right now we don't have one variable, two variables, s and v. So you differentiate the first and multiply by the second. So you'll have 2. When you differentiate s with respect to dt, it's going to be ds dt. Okay? Right, let's have s here. This was s squared. It's s and s. If I'm going to differentiate with respect to s, it's going to be 1. But I'm going to differentiate with respect to t, this is going to be 1 multiplied by ds dt. Okay, so I have only ds dt. Alright, multiplied by v plus 2s multiplied by dv dt. I did the left hand side. Let's do right hand side. So this is going to be 4 sine theta. So it's going to be 4 sine theta d theta dt. I finished that. Multiplied by omega. Plus the derivative of the omega multiplied by this. So plus 4 sine theta d omega dt. Okay, let's use these two equations. I have equation number 1, equation number 2. And before I start, let's find out what is 0. Right now I have constant acceleration, so the linear acceleration is 0. So dv dt is the linear acceleration, right? So this is 0 because a is equal to 0, constant velocity. Here I have d theta dt with omega, so this is going to be omega squared, and this is going to be alpha. So I can actually reduce this equation to be ds dt is going to be v, and I have another v, so will have v squared, and this is going to be 0. This is the whole term. I have d theta dt omega and another omega, so this is going to be 4 sine theta multiplied by omega squared, and this is going to be alpha, so I'm going to have 4 sine theta multiplied by alpha. Alright, so I have this is equation number 2. Let's see how we can find omega and alpha. Alright, I have v, and actually it tells me in this problem determine at theta equal 30. So I can get, so let's find what we have here. So at theta equal 30, I can substitute in this equation and get s. So I will have s squared is going to be equal to 5 minus 4 sine 30. It's going to give me s is equal to 1.239 meters. I got s, and I have the velocity is equal to 2.5 meter per second. Let's substitute in equation 1. So I have equation 1. I have 2 multiplied by 1.239, 2 multiplied by s by 3, multiplied by 0.5 is equal to 4 sine 30 multiplied by omega. I have only omega as the only unknown here, so this is going to give me that omega is equal to 0.6195 radian per second. I know omega, I know v, I know s, so I have v, I have theta, I have omega, theta, alpha, so this equation 2, once you substitute, you're going to have 2 multiplied by 0.5 square equal to 4 sine 30 multiplied by omega squared 0.61 squared plus 4 sine 30 multiplied by alpha. I can find from this equation alpha, and alpha is going to be equal to negative 0.4147 radian per second squared. Right, so the key to solve this problem is to find this equation. Once you relate s with respect to theta, Then you differentiate it once to get omega, differentiate it twice to get alpha, substitute with the boundary condition. What is the boundary condition or the restriction that you have? The boundary condition is theta is equal to 30, Vs is equal to 0.5 meter. That's it. Substitute and get the rest of the problem. Does anyone have any questions so far? Okay, so let's move to a different topic.
Oh, how did you solve for S? How did you solve for S?
How did I solve the S? I have the equation s squared equal 5 minus 4 cosine theta. I know theta is 30 degrees, so I can get s squared and then get S. All right. The next topic is relative motion analysis. Relative motion, I didn't do it with the particle dynamics in the first few chapters. I'm gonna explain it right now. What is the relative motion in terms of rigid body dynamics? Relative motion analysis. I did this before, but let's do it again. I have XY axis something like this. And I have my rigid body, for example. Okay, so this is my rigid body. I'm gonna put 2 points on this rigid body. I'm gonna put point A and point B. If I want to describe the position of point B, what should I do with respect to the origin? Origin. So this is my origin, and this is point B. I need to make a line like this, which is a vector, and this is going to be, since this is O, we can say it ROB or RB with respect to O, like this is, or we call it RB directly, something like this. We can call it RB or ROB, but since O is a 0, is the origin, we can remove it. Since B is going to be measured to the origin. Or we can call it RB with respect to the origin, something like this. All this is right. Okay? Alright, same thing with A. So if I want to describe the position of A, it's going to be equal to RA. So this if I want to describe the position of A and B. There is something that we can do as well, like we can describe B as a function of A. How? Do you guys remember in the vector analysis, if you have a point A and you want to get to point B, you can get to point B in different ways. You can have a vector going this way and another vector going to this way. And maybe something going this way and then something going this way. Or directly this way. There's different ways that you can do it. Once you sum all these vectors together, they are going to give you the same answer because it's a vector analysis. Okay? And we call this RAB or RB with respect to A. Okay? So, and if you want to find RAB or RB with respect to A, you can, let's say this is C. You can say RC with respect to A, and then this RB with respect to C. This is going to be the summation of RC because you need to sum this vector and this vector. RC with respect to A plus RB with respect to C. But you're going to say, this is long and this is long and this is much longer and this is much longer. Should give me more length. No, it doesn't work this way with vectors. Because with vectors, you will have to analyze this vector positive and negative. So when you do positive, this goes up. And when you do positive, the negative component of this vector is gonna take out the positive component of this vector that goes up, and you end up like summing just the horizontal component from here and the horizontal component from here. That's how vectors work. Okay, same thing here. So if I want to find RB, I can actually get RB with respect to A. So we can call this RB with respect to A, and I can say here that the vector RB, this one, this position, is equal to, if you want to get to point B, you can take the vector RB right away, or you can go to A and then RB with respect to A. So this is equal to RA plus RB with respect to A. Same thing, if you want to describe RA, the opposite, you need to change the direction of this one. Rather than going from A to B, you make it to go from B to A. So this is going to be equal to RB plus RA with respect to B. Did you guys get that? Like if I want to do it the other way, I need to swap this arrow and make it over there. And RA is going to be equal to RB plus RA with respect to B. So be careful about this and this. Does anybody have any questions? Alright, so this is about vectors. But how this is going to help us with the motion. If we differentiate this one, like let's differentiate this with respect to t. D dt to get velocity. How this is going to be? This is going to be when you differentiate d RB vector dt, and here you have dRA vector dt plus dRB with respect to A dt. This is going to give you VB vector, this is going to give you VA vector, and this is going to give you VB with respect to A vector. But you will tell me, you told me before that this doesn't change, right? Do you guys remember when I told you if you have a rigid body like this, and you have 2 points on the rigid body, the distance between them doesn't change. I put a point here and a point here. Whatever this body's moving, the distance between them is going to be the same. The distance is going to be the same, but the direction is going to be different. Like if point A here and point B here, the distance is going to be the same, but if I rotate this way, the direction is different. Right now the direction is going positive, but if I did it like this, the direction is going negative. So it changed in, it's a constant in magnitude, but different in direction. So I have to differentiate it as well. Okay, so this is, let's see how we are going to use this rule. Let's see how the relative motion is going to help us with moving bodies. Let's say that we have, my body is something this is point A and this is point B. Alright, let's say this is the same body. At some point, this body was in this location. Let's consider this pen. This pen was here, and he did whatever general motion, like rotation, translation, and came to this position. This body could have make like this, or could make like this, whatever motion it did, but this is the final position. So it doesn't matter how this body moved, but what matters, what is the final position look like. So how this body can get from here to here. So let's see what is the most simple way to make this body come from here and make this body come from here and do it mathematically in a very easy way. The very easy way is to do translation, right? We don't deal with omega, we don't deal with anything. A body came from here and moved right here. That's the very, very simple motion. But how we can do this with that? This one is like something like this. So I can't deal with general translation, like if I general translation, oh my goodness, this body moved like this and make like this until it came to this position. So, but what I'm careful, or what I wanna do, I wanna simplify this motion. I can divide it into two separate motions, solve, for example, translation, and solve rotation, every one separately. How can I do this? We can simplify this motion that this body, this point A, came from here to here, translation, and then rotation. It's like this body's like this, and came here. So what I'm gonna do, I'm gonna move this translation to here, and once it got here, I can do the rotation. So I divided the motion into two parts, translation and then rotation. And this is actually what happens here. Let's see how we can prove it. How can I do this? If we look at the, where's the red one? Okay. If we look at the general one, let's say that the A motion was something, for example, like this. Like A was moving this way. This was the direction of VA, and the direction of VB was something like this, VB. This is how this body, this actually the 2 points, have different velocity, different direction, magnitude and direction. And with these two velocities, this is how this body came here. The thing is, I want to transform these two velocities into two separate motions to make this body come here. So how can I do that? Okay, so what I'm gonna do, as I told you, I'm gonna separate the motion, like make it as a translation, like this body verse came like this until it gets here. This is point A and this is point B. And then it did rotation. So how this can happen, this is gonna happen was like two, here, so this is, let's put 2. Plus verse, I'm gonna divide VB into two components. One component parallel to A, so you are gonna have here VA going this way, and this one also is gonna be VA. This is because you need to have a translation, all the velocity on the body need to be the same. So this is gonna bring this body to this location. Okay, gonna bring it this way. Actually, this one needs to be a little bit lower so that you can imagine the motion. It's different from. Let's have this a little bit down. Here you have VA, and this one has VB. So for this point to come to this point, you are gonna have two VAs get to this body on the top. Like this, so these two velocities gonna get this body here. So we divide it to VA. So this is how the first motion look like. So this one is gonna get you here, and this one is gonna get you here. And actually, the point A, to get to A, we call this DRA. This is the displacement to get this going, to get to this point. And this actually should be the same because it's translation. So this is also DRA. And the next one, you need to move this point from here to get to here. So this body needs to move down there. So this is what we call DRP with respect to A. So if you wanna get this distance from here to here, DRB, it's equal to DRA plus DRB with respect to A. So that's what we did. We converted to a pure translation, and then this one is gonna rotate with omega. We need to find actually what is the value of this omega so that we can get the RB. So in terms of velocity, like if we wanna find VBA, so because this is the term that has rotation, so this is translation VA. This one is gonna be the omega of this body, how this omega, how this body can rotate to get to this point. We need to find this omega. If we find omega and we want to find the velocity of this one, so it's the omega plus RB with respect, multiplied by RB with respect to A. So this is going to be omega, the body VA, cross product RB with respect to A. If you, once I get, so this is how it's going to work. You have this body here, okay? Something like this and something like that. This is gonna move translation, so VA, there is no rotation, and then the bar that has rotation, the body is gonna have an omega. You need to multiply the omega by R so that you can get the other velocity, which is this part. Okay, let's put this to example so that we can imagine what's going on. So the main rule that we have, VB is equal to VA plus omega AB cross by RB with respect to A. That's the main rule that we have here. How we came with that is coming from the concept of relative motion. So if you want to find B in terms of A, you plus A with the relative bar. So let's see how, I actually did this last time, but let's do it again. So I have like something like this. Okay, so we have a mechanism like this. This is a joint, and this is a joint, and this is hinge, and this is hinge. And this is point O, A, B, and C. And you have omega to this body, and this is omega of body O, A, right? So let's see how does the motion look like of this body if you have omega O, A here. How is the velocity at point A is going to look like? It's going to go this way or this way? This way, right? And what is the direction? It's perpendicular. It's always perpendicular to this body. So this is VA with respect to O, but I don't have to write O because this is the absolute motion of point B. It's gonna move anyway. Okay, how about point B? How it's gonna move? If this one moves this way, point B is gonna go up or down? Up. Let's imagine. This one goes this way, the whole structure is gonna go down. Okay. But if this one goes this way, it's gonna be tension, so the whole thing is gonna go up. So B is gonna go down, but how it's gonna go down? It's restricted with point C. It's like you have this arm and it's hinged here, so it always goes up and down. It has a track. It cannot. It's a circle track because there's a center here. Okay. So all the motion is like a part of a circle. So and if it goes down, it's gonna be something like this, VB. And definitely there's an omega for this body, omega BC. What if I want to find the value of VA? How can I get it? Knowing the omega of this R. It's going to be equal to, V is the omega multiplied by R, right? I know the omega of this body, omega OA, and the arm is like RA. So it's going to be omega OA crossed by RA with respect to O, or RA. You guys follow with me? Okay? Right. What if I want to find the velocity VB? How can I get it? Knowing the omega BC. It's going to be omega BC crossed by R B with respect to C. So R B with respect to C. Okay. So we got VB and we got VA. There's something also that. So right now we have three moving arms, right? We have this arm and this arm. Each one has omega, right? How about this arm? AB. Is it rotating? Is it translating? Actually, this has a fixed axis rotation, and this has a fixed axis rotation, right? Because it's bent here, so it's fixed axis. This one has a general translation. It's rotating in the space. Okay? So the thing is, this arm have what we call permanent center of zero velocity, right? This is a permanent center of zero velocity. It doesn't move, it doesn't go anywhere. It's always zero. This one also has a permanent center of zero velocity. It's always gonna be zero. But this one doesn't have a permanent center of zero velocity. Okay, why? Because last time we talked about an instantaneous center of zero velocity. So at this instant, where's the instantaneous center of zero velocity? For this arm, A and B. Do you guys remember what should we do? We need to find the 2 points on this body and the velocity direction of this body and make perpendicular to them. Like, okay, I have B, so it's gonna be something like this, and I have A is gonna be something like this. So at this instant, this is the instantaneous center of zero velocity of this body. Okay, that's what we talked about last time. But, okay, so right now I have VB, but can I get for this body the VB with respect to A? Yes. Knowing that this is the instantaneous center of zero velocity, so the omega, there's an omega of this body, but the omega is rotating around this point for this instant. At different instant, when this body starts moving, it's gonna have different instantaneous center of zero velocity. But at this instance, it's here, and this is omega AB. I can find, the thing is, it's very easy to do these two arms, but this one is a little bit difficult. How can I find this omega, knowing this V? The thing is, if you want to find the velocity of B with respect to A, not with respect to C, it's going to be something this way. And this is B with respect to A. This is how can I get it. And what does this mean? That means that this velocity is coming from this R, and I'm getting it with respect to A, so it's gonna be something is going down, something like this. And if I want to find the VB with respect to A, this is gonna be equal to omega AB, the omega of this body, multiplied by RB with respect to A.
That's it.
Yeah.
So what if, just so I understand, okay, what's the velocity of B with respect to C at point B? Will it be the other way?
B with respect to C?
It will be this way, right?
This one.
Okay.
Because this is the line between B and C, so it's something. But B with respect to A is gonna be this way. How about A with respect to B? Knowing that the omega is rotating this way. So it's gonna be something VA with respect to B is gonna go up. Because this is rotating this way, so VBA, and this one is going the other. We're gonna solve examples that we are gonna figure out right now. Another example, just to understand the concept, we have an arm like this, all these arm mechanisms, you need to think a lot while solving them. How's the movement look like, how's the omega look like, but once you solve lots of examples, you are going to understand. Okay, so if I have something like this, and this arm is attached to something, we call this guided support. What is this guided support? That allows this to move horizontally, not vertically, it restrains the movement. Okay, so let's say that this is point A, this is point B, and this is point C. Alright, this is omega of BC. So if this is omega BC, how does the velocity of B with respect to C look like? It's gonna go up or down?
Up.
Wait, so, and it's perpendicular. It's gonna be something like this. So this is B direction. How about VA? If the omega is rotating this way, VA is gonna be horizontal. There's no way that's gonna go vertical because it's restrained as this. It's gonna go in or out.
Left.
Yes, so this is VA. It's gonna be this way. What if I wanna find the omega? How about the omega of AB? like, let's figure it out together. If this arm is moving this way, is the omega BB going this way or going this way? Omega is going this way. This is omega AB. What if I want to find the velocity of V with respect to A? This VB is VB with respect to C. So how's it going to be? So it's going to be definitely perpendicular to the arm and in the direction of the omega, right? So it's going to be something like this. VB with respect to A. Okay? So make sure when you're dealing with omegas and velocity that you are at the same bar. You can't use VBA with respect to A in the bar BC. Okay? In the bar BC we have VB with respect to C and omega BC. Don't mix the velocities. If we are dealing with bar AB, so we need B with respect to A and we need omega AB. Okay? Alright. So let's solve an example on this. It's an easy one, but it's good to start with. Yes.
So we can actually assume that if we know the direction of omega, so the velocity between 2 points is always going to be perpendicular to the arm and the direction of omega.
Yeah, but
Between those two.
every point can have two velocities because it's connected to different arms. So you can get VB with respect to C or VB with respect to A. So that's what I'm talking about. You need to be careful about that.
So it's just depending on the 2 points.
Yes,
Yes, and the omega between those 2 points.
exactly. And it's always perpendicular to the arm and
Yeah.
it's moving. Alright, okay, so let's solve an example. So this is the example from the textbook, example 16.6. Right, so in this example it says the length shown in figure blah 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 is guided by two blocks, A and B. Okay, so you have and you have a link here. You have a block here, and there's a link. And this link this is point B, and this is point A. And it says this link is bounded by the blocks A and B, which moves in a fixed slots at the velocity VA is 2 meters per second downward. So this is VA equal to 2 meters per second and going down. Determine the velocity VB when theta is equal to 45 degrees. And this is 2 meters. Point 2. And this is 0.1 meter. And so determine phi VB at theta, and theta actually is this angle 45 degrees. Alright, so right now we have a relative motion. B is moving with respect to A, and it's only one member, one line. So not two lines, which makes it very easy. Okay, so guys, you tell me, if this A is moving down, what is the direction of the omega of this box? Is it going this way or going the other way? The omega is going to be something like this, right? Looking like this. So V is going this way, and definitely that's the direction of VB. There's no way that it's going to go up. So VA is going in the negative J direction, VB in the positive I direction. that's actually given in the, not given, that's something that you need to figure out in the problem. So when you put VB, you have to put the whole magnitude in the I direction, because this is a key to solve the problem. Same thing with VA. All right, so we only have one rule. If we want to find VB, and there's a relative motion, so it's equal to VA plus VB with respect to A. And I know that the entire VB has a magnitude, for example, VB, and it's all in the positive I hat direction. And VA is equal to 2 meters per second as a magnitude, 2, and it's in the negative J hat direction. How about VBA? So VBA, actually, we discussed this, it's equal to, where's the, yeah, it's over there, omega AB. So you'll have to find omega to get VB. But it didn't ask you for omega, and that actually makes sense. So sometimes, like in the problems, it doesn't ask you for something because you already have to get it to get the second one. So to get to VB, you will have to get omega. All right, so what is the direction of omega? If this is I direction and this is J direction, I'm gonna make this is my K direction, K hat direction. You tell me, with this I, J, K directions, what is the direction of omega? Is it positive K or negative K? With the right hand rule. Right, to make a right hand rule, the omega is rotating this way, so it's coming out of the board, so it's in the positive K hat direction. So in the K hat direction. Alright, we need to cross this with the arm, like VBA is equal to omega crossed by RB with respect to A. How about RB with respect to A? Okay? Not RA with respect to B. So this is A and this is B. If you want to find RB with respect to A, you make an arrow from A going down all the way down to B, and you find what is the vector of this. RB with respect to A. So as I said, arrow from A going to B, A to B, this is RB with respect to A. I have this angle, it's 45 degrees, and I know that this length is 0.2 meters. So let's again, I know the magnitude of RBA, but I want to find the direction because we need to do a cross product here. So how can we do that? You guys can tell me how can I get the vector here? What does it mean by vector? I need a component in the I hat direction and another component in the J hat direction. That's what does it mean by vector? Can you get this vector, RBA, as a function something in I hat and something in J hat? You need to analyze the 0.2 component. One of them in the X direction, one of them in the Y direction. So this is 0.2 sine, this one sine 45, and this also 0.2 sine 45. Okay? So this is actually gonna give you 0.2 over root 2. Can you guys find it? 0.2 sine 45. Do you guys have a calculator? I think it's gonna give you 0.5, right? 0.5?
0.14. 0.14.
Oh. 0.14, okay. Right, so I'm gonna have, this is the vector. This is, how can I get it? This is goes down, and this is goes this way. So this is in the negative J hat direction, and this is in the positive I hat direction. So I have positive 0.141 in the I hat direction, and I have negative 0.141 in the J hat direction. Do you guys have any problem with how to build a vector? Any vector? Like if I'm telling you, write me this vector A, how you can get it? You need to find an angle of this vector, theta, and then you'll find the X component and the Y component. And the X component is gonna be in the I hat, and the Y component is gonna be in the J hat. How? Sine, cosine. Any vector in the world, like something is going down, same thing. You need to find the angle with the horizontal, get the horizontal component, the Y component, put I hat in front of the horizontal component and j hat in front of the vertical component. This is how you can get any vector. Alright, so I have the vector. Right now I need to do the cross product. So right now I have VB as we said, is gonna be in the I hat direction, is equal to -2 j hat plus omega A in the k hat direction, multiply cross product by this vector, which is RP with respect to A, which is 0.141 in the I hat direction plus point minus 0.141 in the j hat direction. Okay, let's do this cross product. If I want to multiply, definitely the values, the magnitudes are gonna stay the same. But how about when I multiply k hat by I hat? Put this in front of you. I, j, k. If you multiply I by j, it's gonna give you k. J by k is gonna give you I. But if you want to, if you went to the other way, ik is gonna give you negative j. Kj is gonna give you negative I. So let's do it. K multiplied by I. K multiplied by I is going to give me positive j, so I'm going to have 0.141 omega in the j hat direction. How about k multiplied by j? K multiplied by j, so I'm going reverse, is going to give me negative I, and I already have negative here, so it's going to be positive 0.141 omega in the I hat direction. Okay, so right now you have VB in the I hat direction equals something in j, something in j, something in I. I can build two equations from this. I can separate the things in the x direction and separate the things in the y direction. So I can say from this equation that you have VB vector in the I hat direction is equal to 0.141 omega minus 2, all this in the j hat direction, plus 0.141 omega in the I hat direction. Okay, so from this I can find out that this is equal to 0 because there is no j hat on the other side. So I can say that 0.141 omega minus 2 is equal to 0 because there is no j hat on the left hand side, and this is going to give me that omega is equal to 14.18 radian per second. It's like getting sum of fx and sum of fy. Fx, I have component the I direction, so VB is equal to this. So VB is equal to 0.141 multiplied by omega, which I just got, 14.18, and this is going to give me 1.96 meter per second. And now I got VB, which is what is required in this problem. Let's see what I did here. What I did here is just one equation. This equation. VB is required, VA is given, and I put it down here. VBA is from this equation, omega multiplied by R. You need to find omega, which I found it here, and R, you need to build the vector RAB. Once you build it from the geometry of the problem, you multiply cross product, you will end up with equation in I hat and j hat. Make the j hat is equal to 0, and the I hat is equal to VB, and then you will find VB. That's a very, very simple problem. Actually, I solved it here in 3 lines, but I have to write many things so that I can explain to you. All right, so I'm gonna give you an idea for another problem. Maybe I will not solve it to the end, but I have another problem here that you have like cylinder and it rolls on a conveyor. This is a conveyor. You guys, when you go to a shopping center and then you put your stuff on a conveyor, so it's something like this. And there is a cylinder here. Something like that. And it tells you that this conveyor is moving with a velocity v is equal to 2 feet per second. And this cylinder is moving with an omega equal to 15 radian per second. Right? And what is he asking for? He's asking for the velocity of point A. And the radius of the cylinder is 0.5 feet. Okay, focus with me. You have a cylinder like this, right? If this cylinder is not on a conveyor, I'm telling you, it's rotating around this center with an omega 15 radian per second. And I'm asking you, what is the velocity at A? That's very simple. You find this radius, and you know the omega, so VA is going up this way, and you multiply omega by R 15 by this radius 0.5, 7.5 meter per second is going up. But the thing is, this is not moving not only about this one. This is moving about this one, and there's a conveyor that is moving and give it an X direction movement. So this A is gonna be a little bit this way, because it's gonna have another component from the X velocity on the conveyor here. So it's moving this way. So I can say that this is not 90 degree anymore. I can say that VA is something like this, because there's another X component is added to it. But how can we add this? This conveyor, the velocity on every point on this conveyor is constant, right? So this one, so the velocity here, let's call this point B, and the velocity VB is equal to 2 feet per second. Right? Okay, so let's take this cylinder out. Here, you know VB is going this way, equal to 2 feet per second. And you know that this one is having an omega 15 radian per second. And you want to find out what is the velocity of VA. So let's find out how we can do it. We can actually get the relative velocity using the concept of relative velocity. So VA, be careful, because what we did before is VB with respect to A. Okay, right now we need to find VA with respect to B. So this equation will have a little bit of a change. VA is going to be equal to VB plus RB, RA with respect to B. That's the change that we have here. R A with respect to B. So right now, because we need to find VA, so we need to make an arrow from here until it goes all the way up to there. That's what we call RA with respect to B. If the arrow goes to the other side, so it's B with respect to A. Okay, right now I know VB. What is the direction of VB? It's a 2. In which direction? I, J, positive I, negative J, positive I hat, right? Plus, sorry, this is D.
Why isn't omega included in that equation?
The omega, this is the velocity. Right now I don't have the omega, but I'm gonna include it. So you are asking for the future or what? Oh, you mean the problem has omega?
Yeah, like
Because that's how's the problem like built. Like tells you that you have a build and there is something that is rotating on this build. This is how the problem is given. It doesn't say that this body doesn't move. If this body doesn't move, it's gonna have the same velocity like this one. It's gonna move 2 meters per second. But what happened is this conveyor is moving and this body is rotating at the same time. Right? Do you know how this actually is shown on a video? Like, do you know the little stick?
Yes.
Okay, so you put it on a conveyor when you check out from Walmart or something, and you give it like a little bit of a rotation. So it's keep rotating while the conveyor is moving. Okay? Alright, so let's continue. So you have VAB. How can I find VAB? So that's what the omega is going to kick in. So this is going to be the omega of the entire body. You have A and B, so you have omega crossed by RA with respect to B. And that's very easy to get. I need to find the direction of the omega. The direction of the omega is in the negative K hat because it's going inside. Let's write it here. So you have VA. It's going to be 2I plus the omega is 15 in the negative K hat direction crossed by RA with respect to B. If you want to find RA with respect to B, You guys tell me, here's the center, this is 0.5. Can you tell me what is VA with respect to B? How can I get to A? I need to go up and then it goes this way. So it has negative 0.5 in the I hat direction plus 0.5 in the J hat direction. Right? Yes. And then you multiply cross product, and then once you are done, you will be able to get VA. And you can use the formula out there. Do you guys need me to solve this problem? You multiply K by I. So K by I is gonna give you J, and be careful about the dimension. Multiply K by J. K by J is gonna give you negative I, and be careful about the dimension, and then you will find VA finally is gonna be equal to 9.5 in the I hat direction plus 7.5 in the J hat direction. And actually that's a very, very simple solution. Why is that? If you want to find out what is the velocity from like the common sense, you have omega 15, right? And you have the radius 0.5. As I told you, multiply omega by r. 15 by 0.5 is gonna give you 7.5. And that's where 7.5 from here and 7.5 from here. Like it's like in the when you multiply them, it's gonna give you 7.5, and you have another 2 coming in the I direction. So you are gonna put this 2 on the 7.5. So it's gonna give you 9.5 in the I hat and 7.5 in the J hat direction. So all what you have here is that without the build, this 2 is not gonna be there, and it's gonna be only to 7.5. This you add it to, this is 7.5 plus 9.5. But let's do it step by step. You have, this is the main equation. Once we say relative motion, put this equation in front of your eye, expand V to be omega multiplied by R, and figure out how to get omega, or is it unknown? And figure out how to get the R, okay? All right, so in the last 5 minutes, I wanna, well, I'm not sure we will have some time to talk about the continuous center of zero velocity, but maybe I talk about the exam. So the TA graded the exam, and the grades are really, really bad. Like the average is like 50. So, well, I don't know why is that, like, but anyway, the final is like in 3 weeks from now, so we need to prepare, because it's gonna be a comprehensive one. You'll have to study the whole subject. So just be prepared, and all the examples are from the notes. Like everything is from the notes. Like at least solve the things that are from the notes. Like I don't remember that I put any problem in the exam not from the notes. Even that I make it more easier from the notes. So you need to focus. Dynamics is a very core course for the civil engineering students. It's one of the most difficult and low passing courses. Make sure that you pass this course so that you get it behind. Don't waste this year. I know there's the attendance usually in this class is low because it's very advanced, people lose interest, but try to keep your interest because you have to pass this class or you will not pass the whole program. So try to focus, try to study harder, and reach out to me if you have any problem. I know it's a very hard class. It has math, it has physics, it has dynamics. You will have to be on top of many basics, but at least do your best. Like try to study hard, try to figure out if you're missing something from the math. That's how we study dynamics. Like, oh, there's lots of math, lots of integration. Let's get the integration notebook and see how did I do this. There's some physics. Let's get back to the physics. Try to keep it. I'm giving like it's from the notebooks. Like try to study the lecture notes. Like the first problem that has the work in the spring, it is from the lecture notes. Just to change it some numbers. The problem that has the ball hitting a wall, it is from the notes. Everything is from the notes. So even when I asked you to explain something that has related with seismic, everything from the just explaining. They didn't ask you to solve a problem. I asked you to explain how is the moon shapes look like, or how the multi-degree of freedom or single degree of freedom. It is not like it is not difficult. So be ready for the finals. You only have 3 weeks. So in these 3 weeks, just to make, if you have something with basics, try to revise how these basics look like and focus on what is new, because definitely there will be maybe 1 or 2 questions about really rigid body dynamics. But also there will be some questions on the fluid, on the particle dynamics. So just be on top of things. That's my advice. That we definitely I'm gonna curve this one maybe to bring the average to 75. So but for the final exam, do your best. Okay. Thank you.
No.